Welcome to the Explainer. Today, we're diving into a massive, but honestly largely unspoken shift in how enterprise artificial intelligence is actually being built right now. If you think AI runs entirely on the flashy programming languages dominating your daily newsfeed, well, you might be missing what's really powering the world's most critical infrastructure. If you're building AI for the real world, this is absolutely the reality check you didn't know you needed. Let's get into it. Here is how we're going to break this all down today. 1. The AI language divide. 2. Java's plot twist. 3. Why enterprises choose Java. 4. The production ecosystem. And 5. The future of AI code. All right, part 1, the AI language divide, or that notoriously huge gap between prototyping and production. Okay, let's kick things off by looking at what everyone thinks they know about AI programming languages. We've got this classic two-language problem in AI. On one side, you have the prototype phase. Data scientists absolutely love Python for this, right? It's got easy syntax, massive libraries. It basically reads like plain English, and it is super forgiving. It's the ultimate sandbox. But on the flip side, you've got the engine, the actual heavy math and those performance-critical kernels, the real beating heart of these models. You literally cannot run those efficiently on sandbox sand. So they usually get executed in compiled lower-level languages like C, C++, or Rust to get that raw speed and memory safety. You basically have the training wheels of Python and the raw horsepower of C++. To put that performance gap into perspective, and this is a wild stat, a recent peer-reviewed study evaluating AI algorithms from scratch found that Python runs a staggering 315 times slower than C. Now, 315 times might just sound like, another abstract tech metric. So let's translate that. A task taking just 1 single minute in C would take over 5 hours in Python. Take a second to think about your own tech stack. In a live production environment, that kind of latency isn't just a minor headache, it's a complete deal breaker. Plus, memory-efficient languages like C++ and Rust manage to keep their footprint super lean, often staying under 6 megabytes, whereas your high-level ecosystems can casually eat up hundreds of megabytes just to wake up. Which brings us to part 2, Java's plot twist, the enterprise reality check. So you're probably thinking, if Python is way too slow and heavy for massive scale, and C++ or Rust are often just too complex or not standard for your everyday backend developer, what on earth is the enterprise actually using to run AI? Well, here is the plot twist. According to Azul's 2026 State of Java survey, a massive 62% of organizations are now using Java to code their AI functionality. That is a bombshell number, up from 50% just the year before. Let that really sink in for a second. The vast majority of the corporate world has quietly made a choice that totally contradicts all the mainstream Python hype. The language that's been the reliable backbone of the enterprise for decades is stepping right up to do the heavy lifting for the AI revolution. This perfectly captures the pivot we're seeing. As Gil Ten, the CTO of Azul, points out here, people just aren't making little lab demos anymore. They're moving AI out of experimentation and into massive, real-world production. I want to really highlight that word functionality, because functionality in the enterprise means guaranteed uptime. It means bulletproof security. It means zero friction integration. Those things aren't necessarily sexy in a research lab, but they are absolutely non-negotiable if you're running a global bank. Moving right along to Section 3, Why Enterprises Choose Java, taking it from the lab straight to the factory floor. Let's get out of theory mode for a minute and see how this plays out in demanding zero downtime industries. When you compare these languages in a production context, a very deliberate strategy emerges. Just look at this breakdown. Yes, for sure, do your rapid prototyping in Python, but Java is indispensable for actually running that AI at scale. Look specifically at that integration row. If you build a killer machine learning model in Python, getting it to actually talk to a legacy corporate system usually means building messy middleware or some custom API bridge. That's just asking for latency and risk. Java, though, it plugs right into the existing mainframe natively. Companies absolutely do not want to rebuild their entire architecture just to deploy a single AI model. Think about what serious production actually takes. In high-frequency trading, AI has to process complex market signals in real time because every microsecond literally equals millions of dollars. Or picture manufacturing. Imagine a huge robotic arm on a car assembly line. If a pressure valve spikes, Java-powered Edge AI can process that localized signal and shut the line down in milliseconds, stopping a massive disaster. That's predictive maintenance in the real world. These environments also demand strict predictability. They need predictable licensing, so there are no surprise vendor fees, and built-in observability, so engineers can look under the hood and spot a data bottleneck instantly. Java just gives you all of this natively. And if you're managing an engineering budget, listen up, because this next point is your bottom line. Scaling AI is notoriously expensive, especially when you factor in cloud compute and GPUs. Well, the data shows that 41% of enterprises use high-performance Java platforms specifically to speed up execution and slash their cloud infrastructure spend. They're quite literally running the exact same AI workloads on fewer, cheaper hardware resources just by leaning on Java's highly optimized garbage collection and memory efficiency. It is a massive cost-saving hack hiding in plain sight. All right, section 4, the production AI ecosystem. We're talking mature tools for serious workloads. Now, you might be sitting there wondering, how are they actually doing this without jumping through a million technical hoops? Well, the Java AI ecosystem has quietly gotten incredibly mature. Just look at the adoption rates for these Java-friendly AI libraries. We've got 45% adoption for Java ML, 33% for Deep Java Library, and 23% for Spring AI. The so what here is huge. It means enterprise teams can fold AI right into their workflows without switching languages. More importantly, it means companies are saving millions because they don't have to retrain their massive existing armies of Java engineers. To stay competitive today, organizations need some very specific, totally non-negotiable capabilities. Let's talk about long-term support, or LTS. For an enterprise, this is the holy grail. If you run a global logistics network, you can't have your core AI routing system break just because some language pushed a trendy update on a Friday. You need a guarantee that the ground won't shift under you for years. Combine that stability with built-in security, deep observability, large data access, and seamless large language model integration, and you've got exactly what Java platforms are purpose-built to deliver at scale. And finally, section 5, the future of AI code, evolving the enterprise stack. So, where does this all leave us? As AI becomes standard business practice, we are entering a genuinely fascinating new era. Get this, 30% of organizations say that more than half of their code base is now generated entirely by AI tools. With AI cranking out all the standard boilerplate code, human engineers are shifting their focus away from basic syntax. Now, it's all about architectural stability, security, and complex integration. Which brings us right back to Java. If an AI is writing your code, you desperately need a language with strict rules and strong typing, so it doesn't just spit out a giant web of spaghetti code. Enforcing structure? That is Java's absolute bread and butter. As this explainer shows, AI is forcing everything to evolve: our code, our hardware, and our operational standards. It's no longer just about getting a cool machine learning model to work once in a controlled sandbox. It's about making it run safely, cost-effectively, and constantly across a massive global enterprise. So you've really got to ask yourself, is your current tech stack genuinely ready to handle the sheer scale of tomorrow's AI? Or is it still just built for the lab? Thanks so much for joining me for this explainer, and remember to always keep questioning how the technology around this is actually built. Catch you next time.